functions can have different properties. So there is one-to-one, onto, and both. And these have two different names. So one-to-one is the same as injective, onto is the same as surjective, and both is the same as bijection. Remember this bijection, we're going to use that in just a little while. So let's talk about what each one of these are. So a one-to-one property means that every element in X, or every element in the domain, maps to a different element in the target. So notice how both 9 and 15 map to 7. Now this is legal. This is still a well-defined function, right? Because 9 always maps to 7 and 15 always maps to 7. So it's well-defined because each element in the domain maps to exactly one element in the range or in the target. So it's well-defined, but 9 and 15 both map to 7. So this one is not one-to-one. To be one-to-one, each one has to go to a different element in the target. So now this is one-to-one because each element in the domain goes to a different element in the target. So that's what one-to-one means. Onto means that the function maps onto every value in the target. So notice how this one doesn't map to every value in the target. There's this 18 that doesn't ever get mapped to. So this is one-to-one, but it's not onto. So what does onto look like? The property onto means that the function maps to every element in the target. So what that means is the target and the range are exactly equal, right? They're the same thing. So now what we have is we have a function that maps to every element in the target, right? So that's called onto. Now notice it's not one-to-one because 18 and 22 both map to 10. So this one has the property of being onto. This one has the property of being one-to-one, but not onto. What about both? That's the bijection. And both is when it maps to, it's both one-to-one. So here we have a one-to-one. Every element in the domain maps to a different element in the range. And we have onto because the function maps to every element in the target, right? So this one is both. It's one-to-one and it's onto. So this has both properties. This is what we call bijection. So these are just different properties of functions. They're all still functions and well-defined, but these properties become descriptive when you're talking about functions. You can say something about the function and know what it means. Functions can be equal, and for two functions to be equal, they have to have the same domain and the same target, and every element, every function x, so the result of the function when it acts on x has to match what it would act on the same result in G. What that means is each value in the domain produces exactly the same value in the target for both functions. So every element has to match, have the same domain and target, and every element has to map to exactly the same element. And that makes them equal. There are a couple of functions that are interesting that we use a lot in computer science, and so those become useful. In fact, so useful that they usually, with most languages, it's a property that is easily available in a computing language. One is the floor function, and what it does is it rounds down to the nearest integer. So 2.8 would round down to 2. What's the nearest integer when you go down with a negative number? Minus 3.2. If you're going down, the next integer you're going to get to is minus 4. 8.1 rounds down to 8. 10 rounds down to, what's the closest integer when you go down, is 10. So that's the floor one, and it always rounds down to the nearest integer. And here's some examples that demonstrate that. The ceiling is like floor, but it rounds up to the nearest integer. So 2.8 would round up to 3. Negative 3.2 would round up to negative 3. 8.1, even though it's only a little bit over 8, it'll round up to 9. And what about 10? it'll round up to itself to 10. So those are two functions, the floor function and the ceiling function, that we see show up in computer science quite a bit.